Hello dear viewer, Assalamu Alaikum. I am engineer Muhammad Rezaul Haq from Automation Tools YouTube channel. We know in industrial automation different type of PLC are using. Siemens PLC is most usable PLC of them. Today I will discuss how can we make a subroutine or function block in Siemens PLC S7-300 CPU. Before start my video, I request you, if you don't subscribe my channel, please subscribe. If you already subscribe, thank you. Also like, comments and share my video. So let's start. First we open step 7 MicroWIN. This software is used for programming in S7-200 PLC, Siemens PLC. Here first this program can be made by three ways. First we have make a scaling system, then we go to the analog input, then we make the main program. So here we make first the scale, so it is make it rename is scale, SCAL, scale. We want to make a scaling, that can we use that means we want to make a function block. This function block we can use in the main program. In the many input we can use this scale function block. So first we design this or make this, then you go to another one. Here is the symbol. First we design symbol. You know analog program is the 4-byte system, so it is make an LDD. So first we define the scaling symbol, then we make the scale program. First we put the input in input. This input is our real value, so we select in the real. You see it's automatically defined LD04. That means it is the real value and it is the 4-byte system, so it is given the LD04 input. You can make an comments is here. It is the input value, input value. We make it the rename, sorry, make a comments. Then we go to the here the scaling input, so we making a scaling input, so we have the high value and low value. So we put the high scale value, we put high scale input. So we make high scale input, that is the scale value high point. It is also real, so we make it real. Its rename is here high scale input, high scale input dilam. Then we go to the high scale input, then go to the low scale input, so it is low scale input. We define it low scale input. It is also real value, so it is real, that type is real. Eta ki low scale input. Okay, then high scale is finished, low scale is finished. Now it is in the highest output, low output. We need the two output. The range output to it is the integer value, so it has two input. So we define high scale out. High scale out we define. It is also real, so we take it real. তাহলে কি হলো, comments we make it high scale output. Same things we make design low scale out, makes low scale. It is also real, so data type is real. Diki low scale output. See, low scale output data type is we define all the input. Then we go to the output that we want to output, so we go to output we define is directly PVQ output, we define it. and it is also the real. So say real, you see 20. Okay, it is output. We comment its output. Okay, we are define this symbol because if we define this symbol, we can easily understand the scaling program. For that reason, I am making the symbol program. Then here define another temple that so we help in the program. So we make it sub high low input. Okay, for my understanding, I make it high low input. Okay, it is also the data type is a temple. It is the real data type, so we make it real. Again, this output I want to put this high input low input. That means another one is sub high low output. I define is output. It is temple and is real type data, so it is real. Then I design the say multiple underscore real. Okay, this is also real type, so if put real. Then we define another one division real. This is also the data type is real, so there you see I have already all of the input is defined. That we need to input method making the scaling program. So all the symbol are defined completed. Now we start the scaling program that we have to be designed. This is the equation that we can flow this the equation by using this equation. This is the output of y, this is the output y, and this equation is a scaling equation. So we make the logic program, that means the program that we can using this equation. This equation you follow. Here you see only is output, the x is input, y is output, high scale range value, low scale range value, and this is the key output scale value. It is the input scale value. It is the high input scale value. It is input scale value. The input scale value, it is the input scale value high, input scale value low. It is the input. It is the output scale value high, it is the output scale value low, and it is the input scale value low. By using this equation, we make the logic program. So start. First we insert a normally open contact SM0.0. It is the normally close contact used. Then we insert an sub real. It is sub real. So we go to the floating point math. Here you can see sub real. Insert the block. Here we use the input value. Which one? This is we use the input. You see high scale value. This is a here we input the high scale input. That means LD4. You see LD4. This is the high scale. Then we use the low scale. We want to make the difference. You see, if this on this is minus L, we making this one by this block. So here we select the LD8. You see, high scale input and low scale input, and different we put this where is LD14. We want to put this here, so LD24 here. Select LD24. We put this one. That means we by difference between low input and high input, place in this get the LD24. Now we make another one. Sorry, first we make the output scale input. So we change this one. We make the output scale input LD12 and LD15 16. We make it, no problem. And we put both in the 28, LD24, put in the 24. Okay, then we go to the another one is we can output make. So we put in the output 28. That means the output, first we place the output, then we insert another subreal. It is also can make the input, output input, no problem. You can subreal. In subreal is, that means we put in the x input. Which input? It is the input value, that means LD0. Then we subreal we have to be input minus the low scale output, low scale input is LD8. So we want to define this one. I tell you which one, this one I show in the equation, LD8. You say low scale input, which one? In equation you can see I make this one input minus, this is the low scale input. Which one? This low scale input. So we make this one low scale input. Then we put this one is where we put in this one 24, LD24. Where it is post board in LD24. You see, that means we make subreal 2. Then we go to the, we want to multiply this output and this output. So we insert the another program is mulreal. You see, this 2 was I make is, and see here you see this one and this one is the multiplying. So we make this one. So one output is LD24 and another output is LD28, and both are multiply and put in the LD32. You see, we, that means we this and this, that means which one? In equation you can see this one and this one is multiplying. So this subreal and this subreal multiplying in the real, pushed in the here. Then you see what's the another one? You can see in equation we make divide which one? So in the equation you can see in division 32, this is the input. So we make the subreal in input, another subreal is, which subreal make an difference, make difference between, we put in the here. You see, we want to the subreal, we define another subreal is here. We don't that means we don't subreal is input and subreal is output, high scale input, high scale output. We both this one use, this one and this one we use. So we make another symbol is sub, subreal is sub sub underscore real. It is also real value. We put real is 40. We use this one 40. So we go to the, which one we want to make this? We want to make this the output scaling. That means the LD4 and 5. You see, this is the two input. We make the between out input this one. So high scale is a LD4 and another is LD8. Two difference, we making two difference. With this one in equation you can see these two difference. This is the high, this is the low. High scale input and low scale input, making the difference. Okay, minus put this one where is LD40. If this is the define, you can give as per your understanding or as per your also comment, you can make add your requirement, no problem. We make the input device and go to, and this device, now you see this output and this output in the multiplying factor, division factor, you see this and this divided by this. So in the program we use division real. Which one? This one and this one. That means LD 32, this divided by LD 40 divided, and this put in the LD 36. Now we, in the equation, you see in equation this and this up to this one is completed. Now plus L. L means our L is the low scale output. So first we have to be in add function, add real. In add real we have to be use this on the last output. So we have to be use last output is LD 36, and our input is which one? This is the low scale output. Which one? Low scale output is the low scale output. So we use this one. Low scale output is LD 16. You see, this is the low scale output. This output is add, and final output is in the PV. That means the output is PV. So we else here is put LD 20. This is the final output. That means, dear friend, you can again I can explain this the scaling logic program. In the scaling logic program, we have the first block, we have used the difference between the high scale and low scale of this output value. This is the difference we have put in the LD28, and that is the sub-real is input value to the low scale input. You see, low scale input defines the low scale input. This is the first one, the output. This one the output. This is the low input differential, and multiplying this one in this equation, you can see this is the first one is HL. This is this function block is for the H minus L, and this is the block is used for the X input 6430. It is the low scale output, low scale input. You see this one. Then we have multiplying this both this one and this one is multiplying. So this output and this output is multiplying. In another function block, subreal is used for this one. For this function is the subreal. Then this and this output divided by this output. So this multiplying factor in output and the subreal output divided by, and then get this on the output. Then we go to the in equation, you can see this output are is plus, that means add in the low scale output. So we have make another function block is add real, and this in add real first input is the equation output and the low scale output is added, and final output is go to the LD24. It is in the scaling equation. In this scaling function block we have make, and this function block we can use in the different program. It again and again you can use and put the values as per our requirement. So I make subroutine program for the analog display system is completed. Now I will show it is working or not. I download this program into the CPU and show it is working or not. You see, first go to the compile. This is a compile. Is compile 0 or you have an error or not? You see, no error. That means you can download this. Go to download. Communication failed, so it try to communicate. I am trying to communicate the CPU was found and press OK. Now press the download. Go to stop. PC is running. You see, program is downloading to the CPU. Saying that run mode, yes, press OK. Now I go to the monitor mode, that is working or not. You see, this program is active. That if you put the input is here, it is the input. I have the input, force input. If you then you go to then the program will be active. So dear friend, I have successfully completed the subroutine numeric scale. That means I want to display the analog display. I will show the step by step. It is one step of the analog display system. So in the next video I will show how can we make a analog input for the S7-200 CPU. At last I will say, if you like my video, please subscribe my channel. If you already subscribed, thank you. Also like, comments and share my video. Please subscribe my channel and press the bell icon. Also like, comments and share. Thanks for watching.